Okay, so today, before we even start constructing a centroid, boys, stop talking, pay attention. Shh, 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 shh. I'm recording. First thing I need to do is figure out what in the heck is a median. So all a median is a line segment. It's a line segment from the vertex of an angle to the midpoint of the opposite side, okay? So a median, all it is a line segment from the vertex of an angle to the midpoint of the opposite side. Okay, well, that means what we need to do is find the midpoint of the opposite side. And I'm just gonna use my ruler, and I like centimeters because they're easier to work with. And I'm just gonna find the midpoint. Okay, so I'm gonna take this, and I might label this triangle A, B, C. Right? So I've got angle A, angle B, and angle C, okay? So if I need the midpoint, I'm just going to measure this, and I think it's about 12, isn't it? I got about 12. Okay, let's go ahead and measure it. That's what I got, about 12. So 6 is the midpoint, right? All right, that's easy. And so I'm going to then just simply draw in, my median. So median's from the angle to the midpoint. That's my median. So I'm just going to draw this picture. Boom. Okay. Well, I need to find all three medians. So let's measure BC. BC, I got about 9. I'll say 9.6 because it'll be easier to divide. I got about 9.6. Divide that by 2. Let's see, what's 9.6 divided by 2? About 4.8. So 4.8 is about there. Okay, 4.8. Okay, so I went to the midpoint, and then I'm just going to draw in the median. There you go. Okay. So far, so good. I'm also then going to do the median to AB. Okay, I'll measure. Looks like at about 11. About 11. So if it's 11, I'll go 5.5 or 5.5, right? Okay, 5.5. And then I'm going to draw in my median. This is pretty easy, isn't it? Okay. So, I've got them all three drawn. They intersect at a point. Let's call that point P. Okay. And I'm going to label these medians. Let's call them X, point Y, and point Z, okay?
Mr. H, what was the point between A and Z?
I think I got 11. Let me double check. I think I got 11. Yeah, I got 11. So in half that was 5.5. Okay. Am I getting too fast? Am I getting ahead of you guys?
No, I'm just going to fill.
Okay, so I basically just found the middle of each side, right? Just found the middle. I measured it. Took half the measurement to get the middle right. I measured it. Took half of it to get the midpoint. Measured it. Got the middle. Okay, and then I just drew in all the medians, okay? I got a point P. And with point P, then I drew all of it. Now, the centroid is like the center of the triangle. It's the balance point. If we could literally pick this triangle up and put it on our finger, it's the balance point. Isn't that cool? It's the center of mass. The centroid is the center of mass. So the centroid is the center of mass. Or the balance point, right? Or the balance point. So if I had a triangle that was made out of metal, right? Big piece of metal, right? I could balance it. I could do a magic trick, and I could balance the triangle on my finger at that point called the centroid. Okay. Now, what happens is there's no circle that goes around or inside of it, but it does have a relationship, okay? In fact, if I measure this, okay, I just want you to watch. This is about 5.5. This is about 2.5. This is about 6. Ooh, this is a good one. 6, and this is 3. Oh, let's do this one for sure. You'll see it. This length is 6, and this is 3. So what happens is this piece will always be twice as long as the shorter piece. Yeah, this is about 7. And guess what this is going to be? About 3.5. What do you know? Okay, thank you. Okay, so here's what we know. We know that in this situation that AP is equal to 2/3 of PY. 2/3 of it, because it really breaks the whole thing into thirds. And the way I like to look at it is this, okay?
2/3 of AY?
That's what I meant, AP, PY. No, AP and PY.
AP is 2/3 of PY.
Yeah.
2/3 of PY.
No. If I multiply PY by 2/3, which is less of it, I'll get AP. Does that make sense? Okay, Tim, think of it this way. If I took 2/3 of AP, I would get PY. If I multiply, okay. Now, here's the way I like to do it, okay? Okay, watch. Here's always an easy way, because the 2/3 always confuses me, but let me show you an easy way to do it, okay? Everybody watching? Okay, watching? So, if this is 3, we just measured, right? This would be 3, and this would be 3. So really it breaks the whole thing into thirds. See how I did that? Okay, it really breaks it into thirds, okay? And the same thing is true here. If I were to measure this, and this is about 2.5. It's about 2.5, 2.5. So this would have to be 5, right? This would be 2.5 and another 2.5. See how that works? Right? Pretty easy? And then if I measure this one here,
we already know that that's 9 times 3 and 6, and then that one would be 10.
There you go. Another 3, another 3, 3. Okay, does that make sense? Okay, that is the centroid. Now, of course, over on the board, you guys can see it. See the centroid? Talks about medians, and it's got 2/3. When you see 2/3, break the whole thing into 1, 2, 3 parts. Okay? All right, ready to turn the page? So far, so good?
Yeah.
Easy, right? Okay, turn the page. Okay, now, construct the orthocenter. Now, actually, the orthocenter is pretty easy, okay? Okay, the orthocenter. So what is the orthocenter? We've got to do the altitude. So let's define what an altitude is first. What is an altitude? Okay, really what the altitude is, boys, you got to listen. The altitude is the true height. The altitude is the height of the triangle. So the height of the triangle would be like right there. You guys agree? How tall the triangle is? So we go, the height of the triangle is like right there. Everybody agree? Right? So the altitude is simply a perpendicular line from the vertex to the opposite side. Okay? Now, it's got to be 90 degrees, right? So, I'm going to make sure I get 90 here, right? So I got about 90 degrees right about there. So you can eyeball it a little bit, right? But we just got to make sure that when we draw these, let me draw the first one, okay? You guys watching? Let me draw this. Sure. Yeah, here. Okay, yeah. Or we can eyeball it, but the main thing is that it goes straight down, okay? Oh, kind of missed. Okay, now, let me draw the first one. Okay. And let me make the most obvious assertion. These two sides are not equal, are they? They're not. They're not. They don't have to be. The only way these two sides will be equal is if either it's an isosceles triangle or an equilateral. But if it's just a scaling triangle, so it's just perpendicular from the angle down, okay? Does not bisect. These two sides, they don't even look equal. All the altitude is straight down, so it's the height of the triangle. Now, if I want to draw another altitude, for me personally, when I draw the next altitude, I just like to take my paper, scoot it around, because then I can see a little bit better. So I just like to take my triangle and scoot it around. And I need the next altitude, straight up and down, right? Right about there. Okay, 90 degrees. Oh, I probably should use a protractor. That looks a little bit off, right? It's all good though. Okay. And then finally, the last one should go like right straight here. I turn my triangle one more time all the way around, all the way around. Okay. Oh, I think I'm off on this one, but you know, I'm going to use, ooh, I am off. Darn it, I should take more time. Should use my protractor. I'm definitely off. I am off. There we go. There, I saved myself by trying to make it look better. Okay, so this point P is the orthocenter.
Mr. Davis, I'm sure he is.
Okay, want to do it again? Okay, watch. Okay,
Come on.
90 degrees, straight up and down. So turn your triangle. Okay,
So you just have to make 3 like 90 degrees.
right, 390 degrees. Okay, so
Oh. Okay.
Price, stop talking.
Okay.
So when I get done, I get the center point of all the altitudes, and that's called the orthocenter. But here's the thing about the orthocenter. It doesn't give you anything. Nothing. It's not the center of the triangle. You can't draw a circle around it. It's really kind of.
Please excuse the interruption. Class of 2021, those students in Miss Hagedorn's advisory. Your turn to schedule. Miss Hagedorn's advisory, head up to the Commons, please. Thank you.
You said the orthocenter is the center of all the altitudes?
Yes. Yes. So let me finish this up. So now, when I do the orthocenter is just the intersection of all the altitudes. But nothing big happens. It is not the center of a circle. Shh, boys, stop talking. It doesn't bisect anything. It doesn't make any special things. The only thing is, if it's an obtuse triangle, okay, I'm going to write this down. If you have an obtuse means bigger than 90, right? If you have an obtuse triangle, the orthocenter will be outside of the circle, okay? We're going to look at that in our journal, okay? Now, we're going to shift, when you get done constructing this, we're going to shift outside the triangle.
Altitude.
Orthocenter.
You're really good at spelling.
Yeah. Ortho, I need a TH, don't I?
Writing this down.
Orthocenter. Okay? Oh, my